Welcome back, guys. We'll move ahead with this integration chapter. This is video number 3, and today I'm going to teach you substitution. So, what exactly is substitution? Look at this. This is theorem 4. F of let's say any function x is like defined as phi of t. It's a differentiable function of t. X x can have any function in form of t, and that is differentiable function of t. Then integration of f of x becomes integration of f of phi of t into derivatives of phi of t dt. Means what? Means exactly this. Say suppose integration of log x raised to power 7 upon x dx. Now that is considered as I. So here we're going to think something about the substitution. Now how to think about the substitution, guys? Or which function and what is the derivative of that function? Of course, we can see the log x. Log x is a function, and the derivative of that log x is 1 upon x dx. Isn't it 1 upon x dx? We could easily see that. So we taken that let log x as t, and then differentiate on both the sides. We're going to get 1 upon x dx is equal to dt, and then integration. Integration will become. Look at this. See carefully. Integration of log x we have taken, that is considered as t raised to power 7 as it is, and dx upon x is substituted as a dt, isn't it? And now this is called as substitution. Very typical and interesting part over here. So integration of t power 7 dt. Now what is this integration of t power 7? It is simple, t power 8 upon 8 plus c. Now t can be resubstituted. What was the t? T was log x. So integration will become log x raised to power 8 upon 8 plus c. That's it, isn't it? Very simple, guys. I hope you have understood. You can pause over here and copy this quickly in your book. Charlie, guys, we'll do ahead with the next sum. Okay, now student, let's see sum number 2. How do you do this sum number 2? So what is I over here is integration of 1 upon 2x plus x raised to power minus n dx. Okay, you can start writing now. So what is x raised to power minus n? Basically it is 1 upon x, isn't it? So we can simply write down these as integration of 1 upon 2x plus 1 upon x power n. This should be 1 upon x power n dx, isn't it? Now, if we take the LCM over here, what will happen? This will become integration of, look at this. Let's first of all take in the denominator. This will go and get multiplied with this, isn't it? So, 2 power x n plus 1 plus 1. And in the denominator, this x raised to power n will go up, x raised to power n dx. I hope you understood what I have done. Okay, if you are not understanding, it is because this index is x raised to power 1 into x raised to power n will become x raised to power n plus 1, isn't it? Whenever the bases are same, we add the powers. I hope you understood this how. And whole thing upon, instead of writing whole thing upon, I have written that in the numerator. 1 upon 2 can be written as 2 upon 1. Isn't it? This third denominator goes and multiplies by it. This was like, the trickiest part of this step. If you know this, then that's fantastic. Now, how to solve this? So, here we will going to do something called a substitution. So, let's substitute. Let x power n plus 1, x power n plus 1 is considered as t. Now, if we differentiate both the sides, what will happen? If we differentiate this, it will become n plus 1 x raised to power n dx is equals to dt. So, basically this x power n dx can be written as dt upon n plus 1, isn't it? This will become constant. X power n dx will become dt upon n plus 1 will come on this side, isn't it? Now that can be substituted. Look at this. Now our substitution is ready. X power n dx we got as dt upon n plus 1, isn't it? We got that as dt upon n plus 1. So let's come back over here and do substitution. Okay. Integration of x power n. What is it? X power n dx. X power n dx can be written as dt upon n plus 1, isn't it? And what about this? 2. What is x power n plus 1? We have to consider that as t. 2t plus 1. Hope you understood this. Till here everything is perfect. Now, now understand this. This is like the constant, isn't it? So I can take that out. 1 upon n plus 1 common outside. Integration of dt upon 2t plus 1. Now how to do integration of these integration of 1 upon x क्या होता है? It is log mod of x, isn't it? It is log mod of x. So 1 upon n plus 1, it's a constant. We will keep outside only. And what about this integration of dt upon 2t plus 1? It will become log mod of 2t plus 1. We've learned exercise in 5.1. 1 upon integration of 1 upon x is log of mod of x upon, and since the coefficient of t is 2, so I'll have to write upon 2 over here plus c, and that's it guys, that's it. All is the answer. So integration will become log of, okay, simplest version will become, okay, it's not bracket guys, it's not a bracket. Once again I'll just erase them and I'll write them as a mod function. So this is mod function. Many people think this is as a bracket. It's not bracket. It's mod of 2t plus 1. Again, I'll have to change it here also. This will become log of mod of 2t plus 1. And whole thing upon, if we multiply this, it will become 2n plus 2 plus c. I hope you understood this. Anyone has any doubt? Okay, this is not in bracket. This is, I mean, this is not in mod. This is a round bracket or open parenthesis and close parenthesis. So this is it. That's it. I hope you understood this sum perfectly. If you want everything on one slide, I have given that everything on one slide. You can copy paste this quickly. Hurry up. Let's move ahead with the next question. Okay, before moving ahead to the next one, just remember that t to be substituted as x power n plus 1. Okay, t to be resubstituted because our t was, isn't it? T was x power n plus 1. So we had to resubstitute over here in the final answer. In the final answer, there should not be anything as t or dt. Everything should be in the format of x. Okay, now it's time to go ahead with the next sum. 4x minus 6. Guys, now the biggest question comes in students' mind, how to choose that t, or how to choose that function as some function or the some number as a t. So let me teach you over here. Let x square minus 3x plus 5 as you can say t, or you can say any variable u also. Okay. So now if we differentiate on both the sides, what will happen? Differentiate with respect to or differentiate with respect to x on the left side and t on the right hand side, or differentiate with respect to x. What will happen? Or you can simply say differentiate on both the sides. Okay. If you differentiate on both the sides, what will happen? When you differentiate both the sides, it will become x. X square will become 2x. Minus 3x will become minus 3. And this will become dx. And that will become dt. Okay. Now we are differentiating with respect to x on both the sides. Okay. So now this became 2x minus 3. Now 2x minus 3 is nowhere over here. But yes, if we take the 2 common out from the numerator, it will become integration of 2. Now could you see 2x? Now could you see 2x minus 3? 2x minus 3 dx. Could you see in the numerator 2x minus 3 dx? Isn't it 2x minus 3 dx? Whole thing upon x square minus 3x plus 5 raised to power 3 by 2. Now could you see how to choose the function and how to take the derivatives and how to substitute? Now, how does substitution happen? Check. Okay, the integration. This denominator was a t, isn't it? T raised to the power 3 by 2. Numerator 2 will write it on that as it is, and 2x minus 3 dx. What is this? 2x minus 3 dx is simply dt, isn't it? Now, how will simplify this integration? Integration. 2 will write it down outside because that's a constant. And t raised to power minus 3 by 2 will be the simplest version and d. Now, what is t raised to power minus 3 by 2? Simple. T raised to power minus 3 by 2 plus 1 minus 1 by 2, and denominator will become minus 1 by 2 d. Now can you take this minus 1 by 2 up, so it will become dd, it will be plus, plus. Now what will happen? Minus 2 will go up, will become 4 and negative 4, and t power negative half, t power negative half can be written as 1 upon t power half. T power half can be written as square root of, isn't it? So this can be written as simply negative 4 upon root t plus, isn't it? Now what was t? T was, so I will become negative 4 whole thing upon, what was this? This was x square minus 3x plus 5. So I can just copy paste. I'm resubstituting as copy, and I'm just pasting, isn't it? So I'll just plug it. That's the value of t and plus c. I hope you understood this sum perfectly. That's it. इतना ही easy है बच्चों, isn't it? ये यहाँ पर क्यों आया? Because this was the value of t. So this is like the whole answer. So this is like the whole answer. I hope you understood till here perfectly. Understood? Uh, so thumbs up. I guess we'll do one more video on the substitution.